Hi! So for today, our main focus is fractions and decimals. So let's start. Of course, we have to start on brief definition of our main term for today, fraction. So a fraction, so first key term that we have here is fraction. A fraction is either a proper fraction or an improper fraction. So let's define those terms also, the proper fraction. A proper fraction is a number representing a part of a whole. So we have, for example, this whole termed here may be a single object. For example, a pizza pie. Pizza. Um, Usually, a pizza is cut into 8 major slices. So, if I ate one pizza, that means I ate 1 over 8 of the entire pizza, meaning that represents a fraction. Or this whole referred in a proper fraction may be a group of objects or a group of persons. So we have, for example, 25 students, and then 5 of them are girls, like that. And then we have another term here, which is improper fraction. Improper fraction is a number in which numerator is greater than the denominator. So that is what we call improper fraction. So the numerator is the number, for example, we have a fraction 1/2. We have numerator, 1 is the numerator, and then 2 is the denominator. And then we also have here the mixed fraction. A mixed fraction is a combination of a natural number and a proper fraction. So, for example, our natural number is 1, and then we have the proper fraction 2/3. So, our mixed fraction is 1 and 2/3. So, I hope this brief introduction of the terms proper, improper, mixed, and then fraction is quite clear with you. I have here a lot of supporting statements that will help you understand or comprehend more about fraction. First, we have two fractions are multiplied by multiplying their numerators and denominators separately. So, in multiplying fractions, you have to multiply its numerators and then multiply its denominators. So here's a general formula. So the product of numerators over the product of its denominators is the product of the specific fraction. So for example, to visualize it further, we have here 2 over 5 times 3/4. So the rule is when two fractions are multiplied, you have to multiply its numerator and then you multiply its denominator. So here we have numerators 2 and 3. So we have to multiply 2 times 3. And then our denominators are 5 and 4. So we have to multiply 5 times 4. So we have here 2 times 3 is equal to 6. And then 5 times 4 is equal to 20. So technically our answer is 6 over 20. So further dividing this to 2 or further simplifying this final answer, we arrive at 3 over 10, which is the most simplified answer. So our final answer is 3 over 10. Next, we have here a fraction acts as an operator of. So, for example, we have here 1/3 of 3. So, if you were asked to answer the question, what is 1/3 of 3? So, what you have to do is multiply it, or 1/3 times 3 is equal to 1. So, a fraction acts as an operator of. So, 1/3 of 3 is, what is the 1/3 of 3? Or when you divided 3 so into 3 equal parts, what is the answer? So 1/3 times 3, that is equal to 1. So that is one of the primary purposes of fraction, to act as an operator of. Another one that we have here for the product of fractions, we have here the product of two proper fractions is less than each of the fractions. So again, to visualize it more, we have here an example. 1/2 times 1/3. So we have, according to our first rule provided here, we need to multiply the numerators, which is 1, both 1. So 1 times 1 is equal to 1. And then we have to multiply the denominators, 2 times 3, that is 6. So our resulting, or our answer is 1/6. According to this rule, the product of two proper fractions is less than each of the fractions. So our answer is 1/6. That is the product. And then 1/6 is less than both 1/2 and 1/3. So again, the product of two proper fractions in the example here, that is 1/2 and 1/3, is less than each of the fractions. So our final answer, 1/6, is less than both 1/2 and 1/3. For the product of a proper and an improper fraction, so the product of them, the proper fraction and an improper fraction, that is less than the improper fraction. So that is less than the improper fraction and greater than the proper fraction. So again, as an example, we have here 1/2 multiplied by 3/2. So in here, 1/2 is the proper fraction and then 3/2 is the improper fraction. So multiplying it again, numerators 1 times 3, and then we have the denominator 2 times 2. So our final answer is 3/4, which is, according to this rule, 3/4 is greater than the proper fraction and less than the improper fraction, which is 3/2. So again, if you multiply the proper fraction and improper fraction, the resulting answer is greater than the proper fraction but less than the improper fraction. So now we have here the product of two improper fractions. So we are referring now here with two improper fractions. Is greater than the two fractions. So as an example, we have here 3/2 times 7/4, in which we can see that these are improper fractions because the numerators are greater than the denominators. So multiplying it, numerators first, 3 times 7, 21. And then denominators, 2 times 4, that is 8. So as a conclusion here, 21/8 is greater than both 3/2 and 7/4. So the product of two improper fractions, in our example here, 3/2 and 7/4, is greater than the two fractions. So the product is 21/8. Again, that is greater than 3/2 and 7/4. So next we have the reciprocal. Probably reciprocal is new to you or not new to you. So reciprocal, so to obtain the reciprocal of a non-zero fraction, this can be obtained by interchanging its numerator and denominator. So to obtain the reciprocal, you have to interchange the numerator and the denominator. So as an example, we have here 3/2. The reciprocal of 3/2 is 2 over 3, wherein the numerator 3 is interchanged to be the denominator of the resulting reciprocal, and then we have the denominator 2 as interchange to be the numerator of the resulting reciprocal. So 3 halves is the 2/3 as the reciprocal of 3 halves. I think I've given a lot of tips or statements that may help you in multiplying fractions. So let's now proceed with division. So while dividing a whole number by a fraction, we multiply the whole number with the reciprocal of that fraction. So again, you have first muna, you have to get the reciprocal of that fraction. And then you have to multiply it to the whole number. So as an example, we have here 3 divided by 1/2. So we have to get first the reciprocal of 1/2, that is 2 over 1 or simply 2. And then we have to multiply it to 3. So again, while dividing a whole number by a fraction, we multiply the whole number to the reciprocal of the given fraction. So 3 times 2 over 1 or 3 times 2 is equal to 6. Next, we have here, while dividing a fraction by a natural number, if you decided to divide a certain fraction by a natural number, so here's what you're going to do. Multiply the fraction by the reciprocal of the natural number. So as an example, we have here 1/4, the fraction, divided by the natural number 2, wherein technically 2 is equal to 2 over 1. So getting the reciprocal of 2 or 2 over 1, we have 1/2. So we decided to divide the fraction 1/4 by 2. So our solution is 1/4 by 1 multiplied by the reciprocal of 2, which is 1/2. So our final answer is 1 over 8. This is our last statement for division. So while dividing one fraction by another fraction, so this is fraction to fraction, we multiply the first fraction by the reciprocal of the other. So we have here, as an example, 1/2 divided by 1/3. So 1/2, we need to multiply 1/2 by the reciprocal of 1/3. What is the reciprocal of 1/3? That is 3 over 1. So 1/2 times 3 over 1 is equal to 3/2. So the final answer is 3/2. So that's it for fraction. Next, we proceed to decimals. So like in the fraction, our main focus first here is in the multiplication. So multiplication of decimals. When you decided to multiply two decimal numbers, or you were asked to multiply two decimal numbers. So first thing to do is multiply them as whole numbers. So treat them as simple multiplication of numbers. And then count the number of digits to the right of the decimal point in both the decimal numbers. So you have to count the count the number of digits to the right of the decimal point in both the decimal numbers. So in our case here, the two decimal numbers, 2. And then add the number of digits counted. So you have to count for the first given number and then the other given number, and then you have it. You have to add it. And then put the decimal point in the product by counting the number of digits equal to the sum obtained from its rightmost place. So as an example, we have here 1.2 multiplied by 1.24. So when we treat this as 12 times 124, that's the first thing to do. So that is, so let us solve. 12 times 124, that is 1,488. So the first step check. Next, we have to count the number of digits to the right of the decimal point in both the decimal numbers. So first, we have 1.2. So in 1.2, we have counting to the right. So we have here one decimal point. So that is 0.2. And then for 1.24, we have 0.24. So that is 3. I mean, that is 2. And then we have 1. So this is 3 decimal places. So lastly, for 1,488, we have to put the decimal point in the product, which is 1,488, by counting the number of digits equal to the sum obtained from its rightmost places. So our sum obtained is for 1.2 we have one decimal place. For 1.24 we have two decimal places. That is why we need to move 1,488, the final answer, by 3 decimal places from its rightmost place. So we have here from 8 and then another 8 and then 4. That is 3 movements. Our final answer is 1.488. So next we have here some sort of special cases. So to multiply a decimal number by 10, hundreds, or thousands, or 10,000s, millions. So how many zeros is that? We move the decimal point in the number to the right by as many places as many zeros. So you have to know how many zeros, of course. So again, I will be completing first the statement. To multiply a decimal number by 10, 100, or thousands, we move the decimal point in the number to the right by as many places as many zeros are the right of 1. So, in simpler terms, as an example, we have 1.33 multiplied by 10. So, we have here 1 0. So, we have to move the answer to the right by 1 because we only have 1 0. So, that is 1.33 multiplied by 10 is 13.3. So, if we multiplied, for example, 1.33 by 100, we have to move the decimal point two places. So, our answer will be 133. So, if we multiplied 1.33 by 1,000, our answer will be 1,330. So, that's it for this statement. Of course, next to multiplication is division. They are quite always come in hand. I mean, they always come together. So, to divide the decimal number by a natural number. So, if we have a decimal divided by a natural number, here's what we are going to do. So, we first take the decimal number as a natural number. So, and divide by the given natural number. So, again, to divide the decimal number by a natural number, we first take the decimal number as a natural number and divide by the given natural number. So, as an example, we have here 1.2 divided by 4. Actually, technically, this is 12 over 4, which is 3. And then, in our numerator, or the decimal number to be divided has only one decimal place. So, our 3, for example, 12 divided 4 is equal to 3. And then, we have a decimal 1.2. So, we need to move the answer 3 to a one decimal place. So, for example, we have 3, and from the rightmost part or rightmost place, we have to move it by 1 because we have here a decimal 1.2. So from 3, our final answer is 0.3. So here we have the special case for division. So I've introduced earlier the multiplication by tens, hundreds, and thousands. Now we have to divide the decimal number by 10, thousands, hundreds. Shift the decimal point in the decimal number to the left by as many places as there are zeros over 1 to get the quotient. So, for example, we have here 1.34 divide 100. So, 100 contains 2 zeros. So, meaning you have to move the decimal point that is between 1 and 3 to the left by 2. So, 1. So, that is first movement, that is 0.134. And then next movement, that is 0.0134. So, that depends on how many zeros you are going to divide. So if you divide 1.34 divided by 1,000, you have to move 1,000 has 3 zeros. So you have to move 3 decimal places to the left. So if you have 10, you only have to move 1 to the left. So I hope that is clear. So here's one of an important note in division. So while dividing one decimal number by another, first shift the decimal points to the right by equal number of places in both numbers, both given, to convert the divisor to a natural number and then further divide it. So example, 1.44 divided by 1.2. So, if you want to achieve a natural number, move all of the given by one decimal place. So, if you move 1.2 by one decimal place, that is equal to 12. And then, if you move 1.44 also, that is equal to 14.4. So, if you decided to move the numerator of how many decimal places, for example 10, and then you must move your denominator also. So when you decided when you want to move a decimal place for the numerator, you have to move also the decimal place of the denominator, because if you will not do it, probably or 100% of the time you'll be having incorrect answers. So our given 14.4 divided by 12 is equal to 1.2. Or you may also first think of 144 divided by 12. So divide them naturally as if you're dividing whole numbers. And then the answer is 12. But then we have here the decimal 144 or is actually 14.4. That is, it possesses one decimal place. So our final answer, which is supposedly 12, will become 1.2. So yes, that's it for today. So if you wish to have a copy of this PowerPoint presentation in the complete module, Fundamentals of Algebra, because this topic fraction and decimals is still included in the module that I made, which is entitled Fundamentals of Algebra. Kindly email me at ryannicole05@gmail.com. Thank you!